Thanks everyone for tuning in. If you'll indulge me, let me just introduce myself a bit. I'm Chris Jansen. I'm a software engineer at Permutive in London. I was at one point a sailing instructor before I changed careers entirely to tech and started out as a network engineer. And somehow I've made my way into the world of Scala and functional programming. I also have some shout outs. Thanks to Ollie, Anastasia and the team at Confi for giving me space to talk. My partner in crime on Trace4Cats, Catastrophe, who's made a lot of contributions recently and really kind of given the project a boost. And finally, my colleagues at Permutive, who have kind of been guinea pigs for this project and have indulged some of my passions. So with that, let's move on. So I'll cover a few things in this talk. First, I'll give kind of an overview into kind of what distributed tracing is, some of the core concepts. Then I'll just briefly touch on some of the libraries and systems, and then get into Trace4Cats itself, kind of writing a traceable application, something on context propagation, and sampling, and then kind of deployment topologies of the tracing system, and then we'll wrap up at the end. So distributed tracing, what is it? It's basically a system or group of systems plus libraries that allow you to kind of follow requests or operations between services in distributed systems. So these could be API calls to a web service. It could be user actions, server operations, or even just method calls within your application itself. And why might you use this? So there's some good reasons here. Firstly, kind of root cause analysis. You might want to see where through a call that originated in another system and failed in a second one, where that call came from and all of the things that it touched along the way. And you can even see which operation has failed. You can use it to map service dependencies within your architecture. So as calls permeate the system, you can trace them and map them out. You can identify kind of hotspots and bottlenecks in your application. So operations that can be parallelized, frequently used code paths, and long-running operations that need a bit of attention. And in some cases, it can be used as a replacement for logging and kind of gives a bit of a richer experience than you would get from logging. And I'll kind of hopefully expand on that a bit more later on. So a bit of terminology in tracing. We talk about traces and spans. A trace is made up of many spans, and then a span has some sort of context. And this context allows us to kind of knit spans together into a whole trace and the operations inside those traces. So a span usually represents a unit of work, and a trace represents all of those units of work stitched together. And spans can contain attributes. And so these are attributes that are kind of relevant to the operation, like say user ID or a count of the number of records returned from the database or something like that. So how this actually looks in tracing systems is something a little like this. So what you have is these blocks, and they generally represent spans. And altogether, that's a trace. So going horizontally left to right, that's your time component, and top to bottom is your order of operation. And I've kind of color-coded them to indicate where the trace is traversing different systems. And sampling. So with tracing, you might produce a lot of traces if you've got a very busy application. But unlike metrics, you can't aggregate spans. You can't just add them together because they're kind of more complex units of data. So we sample or we drop traces, and I'll talk a bit more about this later on. But generally, there's a few different ways of sampling, and they're kind of grouped into two types. Either in the client or app, and that's called head sampling, or in the server or system that receives spans, and that's called tail sampling. So if you're head sampling, you never send or trace the operation. But if you're tail sampling, then you will have traced the operation, but you choose to drop it later on. And then libraries and systems. So a library is something that you would use within your application to produce spans. So this is kind of instrumenting your method calls and things like that. And you can set them up to sample. So that, again, there's various sampling schemes that you can use. And then tracing systems consume spans, and they can forward them on, sample them, and then visualize and index things like span names, trace IDs, and attributes on your spans. So kind of a little bit on the ecosystem in general. There's a few tracing systems. This isn't by any means an exhaustive list, but a few kind of honorable mentions. Zipkin is kind of the first major open source one that people started using from Twitter. And more recently, Jaeger has come along from Uber, and it's kind of the most popular self-hosted one more recently. And then you've got the kind of cloud-hosted ones like Stackdriver and the others listed there. And then libraries, there's quite a few cross-platforms there. They tend to be, for the JVM, they tend to be written in Java. And then there's a few Scala-only ones. Natchez, some of you might have heard of, and I'll go into that in a little bit more detail on the next slide. Pure tracing, which has kind of provided the inspiration for Natchez and in turn Trace4Cats. So what about Natchez? It's this great library written by Rob Norris. I remember when he released it, it was amazing. And it's used in Skunk. He tends to use it in Skunk instead of logging. He's written rationale for this, I believe, on the Skunk GitHub. So that's quite a good read. It wraps existing Java libraries, so it's not. It won't do tracing on its own. You have to import another Java library for it to actually start tracing things. And then it provides support for tracing kind of finally tagless applications via a trace type class, and that is primarily implemented with a Kleisli or a reader T. So let's move on to the kind of the meat of things in Trace4Cats. And it's very similar to Natchez, really, but with a few key differences. It's actually kind of a ground up implementation of a tracing system in pure Scala. So you can use it with Natchez or on its own. And it relies heavily on Cats effect. So all of the concurrency primitives in Cats effect are kind of used to make Trace4Cats. And that means it also doesn't have to depend on Java libraries with lots of transitive dependencies. And this was my kind of main motivation for creating it. I was getting annoyed with gRPC conflict. So it also provides kind of a partial tracing system, which we'll cover a little bit more later. So it can also collect spans from traced applications and forward them onto other tracing systems. So this is made up of an agent and a collector. I'll cover those later. And it provides out of the box the arbitrary context propagation via HTTP. And I'll go into a bit more detail into what that means, but at a high level, it means that you can wrap existing servers like HTTP4S and pass around a trace context between different applications. It also supports combinable exporters, and what this means is that from your application, you can export to multiple tracing systems or log out spans as well as sending onto a tracing system. It doesn't necessarily require reader-T or Kleisli. Its default implementation is using this, but it works with Zio out of the box as well. And although not a key difference, it will interop with Natchez. So any library that uses Natchez, you can just drop in and it will work with Trace4Cats. So a bit on the kind of the supported exporters to date. I won't list them all off, but to highlight, Trace4Cats has its own wire protocol using Avro, and that can be sent over UDP, TCP, and Kafka. So let's look a little closely at a traced application. So to do this, we use this trace type class, which has been essentially lifted from Natchez, with a few different extra methods. But really, we're going to just look at a couple. These two, put and put all, which allows you to add attributes to a span, and span, which allows you to create a new child from a parent. So if you remember in that visualization, you can say, well, given a span, I want to create a child from it. So let's look at this in action. And I'll just define this this trait called Nicolas Cage, parameterized on a type constructor called F, which is our kind of effect type, and a few methods there. So first, for him acting in a movie, that returns a performance, a count of the number of his movies that he's done, which is represented by a long, and an indication of his financial solvency. So how does this look if we were to trace it? So what I've done here is created a wrapping implementation of some underlying concrete implementation of Nicolas Cage. And you'll see here that it takes the trace type class and then can use that when he's acting. So here you can see we're creating a new child span called cage.act. And then we're putting inside, we're putting attributes in that, the movie name, before we call the underlying the underlying implementation. And then once we've got the result from that, we can put some sort of performance level that he's made out of 100. So Nicolas Cage approves of this. So then kind of how does this work on the earlier visualization? I've kind of dropped it into what would be like a HTTP server. So you can see the request coming in, some sort of handler. There's our span that we've defined in the Traceable interface, and he's acting in a movie called Con Air, and his performance level is 1,000 out of 100, as per usual. So how does this actually work under the hood? So in order for the tracing to work, it must be evaluated in some sort of contextual effect. So that's either a Kleisli or reader-T or something like Zio. Anything that allows you to inject some context and get your program out the other side. And the context may be arbitrary, but it must contain a span. And then that context can be updated with can be replaced with kind of an updated value. So let's look at that a bit more closely. So a Kleisli looks like this. This is the definition from Cats. And kind of the most important thing here is what the data type is surrounding this function. So A to F of B. So A, in our case, is a span. And then from that, if you're given that span, you get F of program, and F being your chosen effect. So with this, we can provide implementation of trace. So I've just implemented the two methods that we've used in the previous example. But you'll notice here that trace is implemented with a Kleisli here, and this is using the kind of the kind projector type lambda syntax, which allows us to say that the B that we see above is just a variable and turns it into a type constructor. So in order to add an attribute to the span, we can now say, well, I'll have a Kleisli and I'll return a Kleisli that expects a span to come in. And then on that span, I can modify the attributes and add one. And then in order to get a child span, you can say, well, I'm taking a span on the way in. And then I call this method child, which returns me a cats effect resource of a span that I can then use to run my program. So you effectively get this kind of call stack as you create more children. So let's look at a kind of an implementation of Nicolas Cage and how we would instantiate it to make it trace or traceable. So here's the implementation, which allows us allows him to act, allows us to get the number of movies that he's done and check his solvency. And this is your kind of standard finally tagless implementation. But instead of implementing it with just pure IO, we would say, well, let's do it with a Kleisli. So this underlying implementation doesn't need to necessarily know that it's that the actual effect type is a Kleisli. But in order for the trace implementation that we saw earlier to work, we need the concrete implementation to be parameterized like this. So let's have a look at context propagation. So it allows us to send trace information between our different apps. And like I was showing earlier, it allows us to stitch together different spans and turn them into a whole kind of a whole trace. And these can be passed via HTTP headers. And there's a few different encodings for that. Trace4Cats, sorry, supports quite a few of them, and it's fairly trivial to add them. And then how does this work in Trace4Cats? So there's a few type classes and utilities that will aid development of integrations with servers and systems. And these are kind of effect system agnostic. So like I say, the default implementation uses a Kleisli, but all you have to do is import the Zio support and everything will just work out the box. And again, they're context agnostic, and I'll cover that in a second. And then there's a number of supported integrations like HTTP4S, some experimental support for FS2 because the execution model there is very different to something like a HTTP request. And then building on FS2, the FS2 Kafka consumer and producer. So let's have a look at a HTTP example. I'm going to kind of use pseudo Scala here and some of the types that we see in HTTP4S. So in order to do this, we need to extract a span context from the HTTP request. So we've got this function, and we'll call it make span, and we want to go from a request to a span. And TraceCats does this for you out of the box. You don't need to know how this how to implement this. You can change settings on it, like what header encoding you're going to use, but the defaults should just work. And then you want to execute your program. So your program should look like something like this. So I'm using Wisely here, and your program is I've got a request coming in, and then I want to use that to go to a Wisely, which needs a span to go to a response. So if we expand that, and we'll call it a route. So we need a request and a span, and then that gives us a response. So we can actually compose route and make span to give us a response, just a pure response. And here we go. So we've got route and make span here. And what this gives us is a function that goes from request to response, and kind of fully executes. So arbitrary contexts, what are these? These could be anything really. So kind of user or IAM data that you want to propagate around your system with request. But it could be anything that isn't directly to do with tracing. So how does this look when you're trying to do tracing? So again, we want to extract the context from a HTTP request. So this time we've got a function called make context, and we're going from request to CTX. So in order to do this, the user needs to know how to go from context to span, and then back from span to context, given another context, or given the original context. So TraceCats provides utilities to help do this, and I can go in depth in spatial chat later. But if anybody's used optics before, you'll recognize this as a lens. So given this, we want to execute the program again. And this time, notice that the second type parameter on the Wisely is changed to CTX as opposed to span. And then this time, that expands to, given a request and a context, we go to a response, and then expand that out, compose route and make context, and you get a request to a response. So sampling. Bit more detail on head sampling. So this is taken at the start of the trace, and you would configure it per application. So it might be dependent on the number of requests that you get per app. And there's a few different types of sampler. Always, which means keep everything. Never, which means drop everything. Probabilistic, which is based on the trace ID. So you can say, oh, I only want a proportion of this of the spans that would be created to actually come into existence. And rate-based, which is implemented in Trace4Cats using a token bucket. And then tail sampling. So this is the decision that's taken on the trace system, and you can kind of configure it globally. So many apps send all their traces on, and then you might drop some for performance or cost reasons if you're forwarding onto a cloud provider. And some samplers in TraceCats need to track decisions and coordinate that decision. So we provide a Redis decision store for that. So it's often best to use these two in conjunction. So you might want to set a kind of a global default using the rate limiter, but configure probabilistic sampling on a very noisy service. So now let's have a look at topologies, which are kind of the other side of the TraceCats system. And these these involve the kind of where you send spans and how you send them on. So we'll look at kind of direct export from the application to a tracing system, the agent and collector, and then a bit on Kafka. So here's a view of direct export. So from your traced application, you can send directly to a tracing system like Jaeger, for example, and log out at the same time. So perfectly fine. You might not want to set up a complex topology. You just want to send spans straight on. You don't care about, or you haven't got any kind of library conflicts that are getting in the way. So this is a nice, easy approach. And then there's the collector, where you can send from a traced app to the Trace4Cats collector. And the collector can then do things like sampling and filtering sensitive attributes, and then forward those spans on to a tracing system. Alternatively, if you don't want to send to a collector because there may be some kind of resource contention, you can deploy the Trace4Cats agent that simply forwards spans on to the collector. And this is kind of designed to be like a Kubernetes sidecar or something you would co-locate on a physical or VM. And both the collector and the agent have native image deployments that are in Docker images, so they're kind of very lightweight. So let's have a little bit more of a look at the collector. So the collector can forward spans on to multiple systems for you. So you might send on to a locally hosted Jaeger instance that kind of has a small retention period and then a longer term period on Datadog, or you can forward on to another collector in your infrastructure. And then there's Kafka. So Trace4Cats can send spans via Kafka, which has a few advantages. Like you can load balance the collector, so deploy multiple instances in the same consumer group and have them deal with different traces, or have different consumer groups sending to different systems. So you can send directly from your app to Kafka. Alternatively, if you don't want to have a dependency on the Kafka client, or it's clashing with the client that you're using, the client version that you're using, again, you can use an agent to send spans onto the Kafka topic. And then, as I mentioned, you can deploy, say, 2 collectors in different consumer groups. So listening to the same stream of spans and traces, and you can then have those send to different systems. So you can configure those differently. They might have the Datadog collector might have a higher sample rate or lower sample rate even. So you send fewer spans to save money, but your Jaeger system might see everything, and it has and you're allowed sensitive attribute values in there because you're self-hosting. So to conclude, tracing helps you visualize these call paths through your apps and systems and kind of debug things and build maps and everything. It's quite nice. Trace4Cats is this pure Scala implementation of a tracing system and library with kind of few dependencies outside the Cats Effect ecosystem. And it can export to to many different systems, but you don't necessarily have to depend on those systems' libraries to use them. And it provides a load of context propagation wrappers for various clients and servers, like HTTP4S. And it gives you the ability to deploy in many different topologies, and being able to use Kafka is pretty nice. There's a load of examples available in the repo, and some documentation. As always, it can be improved, but please go and check it out. So thanks very much for listening. You can find the GitHub repo here. And just to say, Permutive are recruiting for functional Scala devs. There'll be roles on the website on Monday, hopefully. So if you like writing functional Scala and maybe want to play with TraceCats a bit more with your day job, then drop us a note or reach out to me on Discord later.